In the previous video, we defined the parameters and the invocation, and we were about to analyze the coding of the procedure. When we start executing the procedure, the attraction ID variable is loaded, and the other one will be empty. First, we have to obtain from the attraction received as a parameter its country and city. We already know how to do this using a for each, which is precisely a procedural command. Thus, filtering by the attraction ID received as a parameter, we locate the desired record, and from it, we extract the values of the attributes country-id and city-id, storing them in these two internal variables to the procedure that we will have to define. Before we continue, let's do that. We write for each attraction, where the attraction id attribute is equal to the input variable and attraction id, and within its body, to a variable and country id that we can define right here by right-clicking and selecting Add Variable. We see that it is already placed in the list of variables. And if we go to the Specific Variables tab, we see it defined based on the attribute of the same name. We assign that variable the value of the attribute for the retrieved record. Then we do the same for a new variable in city-id. Let's save. Now we have to count the number of flights arriving at airports in that country and city. How do we do this? Remember that to represent that a flight had a departure airport and an arrival airport, we had created two groups of subtypes. In particular, the one we are interested in here, the arrival airport. We had seen that, being a subtype of airport IDA, it became a foreign key to the airport table. And from there, we could infer these two attributes, which are the ones we are now interested in. So, if given these two variables, we want to retrieve all flights arriving to the country and city corresponding to their values, it will be enough to use the for each flight command, filtering the flight records for which the country id of the arrival airport of the flight is the country id of the arrival airport, corresponds to the value of this variable, and the city id of the arrival airport of the flight matches the value of this other variable. We know that this for each will iterate exclusively over this set of flights, and what we want is to count them. So there we would place this for each, where we can see that the variables used for filtering were loaded in the previous for each. We want to count the records retrieved by this second for each. So if immediately before we initialize a counter to 0, and inside the for each at each iteration, we simply add 1 to the value it already had. This is what the reduced +SAT operator indicates. Then, at the end of the execution, we will have in that variable the number of flights arriving at that country and city, which is exactly what our procedure is intended to calculate. That is why we use the same output variable as the counter, that for this input parameter 1 will end up with a value of 3 at the end of the source. And this value will be the one returned to the caller of the procedure. So, let's complete the code like this. Let's remove the comment left by the assistant, which is no longer necessary. This is how the source looks now. We may want to ensure that we haven't made mistakes by inspecting the navigation list. To obtain it, it's not necessary to do a run. We can right-click on the object and select View Navigation. This will cause the object to be specified, and we will obtain the navigation list. Notice that here it shows the parameters, and that both for each commands appear. The first one will be a for first, used only to filter by equality, on the primary key. At most, there will be one record that meets the filter. The second for each will iterate over the flight table. and will go to airport only to apply these filters, for which it will have to run through the entire flight table. In a moment, we'll see how we can optimize all this. But first, let's test the solution. We had the data provider get attractions list in which we had already placed here the invocation to this procedure. And where did we use this data provider? We used it in the web panel show attractions. In the start event, we loaded this collection variable, which was displayed as a grid in the web layout, with the data returned by the data provider. We can think of the data provider then also as a kind of function, but one that always returns a structured data type or collection, and whose programming is declarative. In contrast, our procedure returns a simple data type, in this case, because a procedure can also return structured data, and its programming is procedural. Now let's launch a run to test this in action. First, let's see what flights we have. There are only two, the first to Paris and the second to Sao Paulo. Let's add 2 more flights to Paris. Flight 3 from Airport 1 to 2, which is in Paris, with a price of 1,200, and Airline 1. And Flight 4 also from Airport 1 to 2 with a price of 1,650, discount 5, and Airline 1. So now we have 4 flights in the database, 3 arriving in Paris and 1 arriving in Sao Paulo. Then, for all Paris attractions, it must count 3 flights. If there are any from Sao Paulo, 1 flight, and for any others, 0. Now, let's run our Show Attractions web panel. The last line is the one we added hard-coded in the data provider. But the first 2 were taken from the database and the calculation is correct. Let's try removing the filter condition for Paris in the data provider. Let's leave it commented. And let's run again. We see that now, the Great Wall attraction in Beijing is also listed, with 0 flights arriving in that city as expected. Let's see 2 alternatives to this implementation. The first one, we could have defined the input parameter not as a variable, but directly as the attraction id attribute. What does GeneXus understand by this statement? That whenever information involving an attraction is accessed in the source, only that of the attraction id value received as a parameter will be used. It is like saying, whenever, in the context of the command you are executing in the source, there is an attraction id in play, it will be this value and no other. In this case, we have 3 commands. For the first one, an attraction is indeed involved. For this reason, by receiving it in the attribute instead of the variable, this filter no longer makes sense, we will remove it. It will be implicitly applied by the attraction id input parameter. It will retrieve only the record that corresponds to the value received as a parameter. The second command in the source does not involve the database at all, and the third one, another for each, navigates to the flight table and accesses the airport table. In none of them does the attraction id attribute exist. So on this for each, the input parameter will have no effect. Let's try this first change in GeneXus. We remove the ampersand so that the attribute of that name remains. And now we remove the explicit condition of the first for each. We leave it commented out so we have a record of what we did. Let's ask for the navigation list to make sure it matches our expectations. We see that the attribute now appears among the parameters. And for the first for each, we still see the for first and the automatic filter, which now appears indicated with this @ sign. This @sign indicates the attraction attribute parameter. The second for each is not affected at all. Now let's optimize the second for each. In it, we are running through the flight table to count the records that meet these conditions. Isn't that what we were doing with a count formula when we associated it with an attribute in a transaction? When we studied formula attributes, we didn't dwell on the fact that formulas could also be used elsewhere and not necessarily associated with attributes. The aggregation formulas count, sum, max, min, find are also like functions which navigate a table and return a result. In this case, with this count formula, we would be asking to count the occurrences of the flight price attribute. Here we have chosen this one, which we know exists only in the flight table, so there will be no doubt that we want to count the records in this table. But we could well have also chosen flight arrival airport ID, for example. But we don't want it to count all occurrences, but only those corresponding to records for which these two conditions are met. So, what we would do is replace this block of code, where we did the same thing manually and even running through the entire flight table, with this assignment where the result will be the same, but we ensure efficiency because the formulas are optimized. Formulas can also be used in the code of any object. In that case, they are called inline or local formulas, as opposed to formula attributes, which, although they may be present in transactions, belong to the KB and are considered global. Instead of all this then, let's assign to the output variable the result of this count. Let's execute. Here we can see how the for each was replaced by the navigation of the aggregate formula. And if we now execute, we see no difference from the previous implementation. The result is the same, but the code is more expressive and efficient. To calculate the value to assign to this member, we implemented a procedure. But since the calculation was so simple that it could practically be solved with a count formula, we could have thought of adding a formula attribute to the attraction transaction, so we could simply assign the attribute's value to the member, which, as we know, being a formula, is triggered whenever it is required. In that case, we would have avoided implementing the procedure. But if this calculation, the number of flights arriving in the city of the attraction, is only needed for this data provider and nothing else, it makes no sense to have an entity attribute for it. In that case, every time you open the transaction to do something with any attraction, the formula calculation will have to be triggered, consuming time and resources unnecessarily if it's only needed for this data provider. On the other hand, if it were necessary every time an attraction is accessed to obtain that value, then it would make sense to have it as an attribute. Now, suppose the calculation were not as simple as a count formula. Suppose it were a more complex calculation, involving browsing several tables and cross-referencing information. That is, a calculation for which no predefined formula exists to solve it. Then, we would implement the calculation in the procedure, knowing that we can always define a formula attribute as calculable by a procedure implemented as a function. That is, one that returns a result of the same data type as the attribute. Here we see another use of our procedure in a formula attribute. In general, this procedure may be invoked anywhere a value of this data type is expected. One last thing. From a web panel, we invoke in the start event a data provider that invokes a procedure. Where is all this executed? The web panel screen rendering happens in the front end, in the client browser. But system events, including start, are executed in the back end, that is, on the server. So, this data provider is called on the server, and it is fully executed there. From it, for each item, it will call the procedure, which will also run entirely on the server. Once the data provider finishes, the variable is loaded in the server and sent to the client, where it is displayed on the screen in the grid. We have implemented a very simple procedure that received an information parameter and returned a numeric parameter, for which it needed to access the database by executing some commands sequentially. We saw how the parameters were declared using the PARM rule, which is generally used for any object that receives and returns information from and to its caller. An exception, however, is the data provider, which does not declare its mandatory SDT or output collection using the PARM rule, but instead through its output properties. In contrast, a procedure may return nothing and may also receive nothing. Think, for example, of a procedure that empties the entire database or lists in PDF format all the tourist attractions in Paris. It already knows what to do and doesn't need any information from the caller. A procedure can do all that and much more. A data provider may also exchange parameters with the caller, in addition to returning a simple or collection SDT. And to define these other parameters, the PARM rule applies. For example, we may want it to return the collection of Paris attractions of the category received as a parameter. This could be received in a variable, which we would use explicitly to filter, or directly in the category attribute, and it is no longer necessary to make the filter explicit. Although coding in the data provider is declarative, unlike in the procedure, as far as navigation and filters are concerned, the same applies here and there. Also, and no less important, what we had anticipated when studying the for each command in a grid event has been demonstrated. This command could be used in any object where procedural code and database access are supported, such as a procedure. And also, the same navigation logic, in different form, can be found in other objects such as the data provider, in controls such as grids with base table, and in aggregation formulas. Finally, it's important to highlight that we have seen a specific and limited use of an object that has enormous flexibility and power, and is an essential player in any backend.